Okay, y'all, for lesson 2-7, example 1, where it says how many solutions can there be for a linear quadratic system, I want you to use Desmos and graph each one of these equations. So for the first problem, y equals x squared and y equals 2x, go to Desmos, x squared and 2x. As you can see, the graph of x squared, the red parabola here, the quadratic, and the graph of 2x, the linear line, intersect at 2 points here at 0, 0 and 2, 4. So that means that this system has two real solutions. Two real solutions. And then for the second problem that you see there, 3x squared and 3x minus 2, 3x squared and 3x minus 2, as you can see, they don't intersect at all. The quadratic, this parabola, does not intersect at all with my linear line. So that is no real solutions. Okay, and the next one, we have y equals 3. Make sure you type in y equals 3 in Desmos, or if you use the calculator, you just have to type in 3 because the y equals is already given to you. I have x squared minus 4x plus 7. And as you can see, my parabola, my x squared minus 4x plus 7, and my y equals 3 only intersect at this one point. So it's one real solution. And the last one, we have 3x squared minus 2x plus 7 and y plus 5 equals 1/2 x. So as you can see, they do not intersect at all, so there are no real solutions. Oh, I can keep going. Okay. For this next section, example 2, you can solve these algebraically like I have listed here with all the step-by-steps here. However, I would highly suggest doing Desmos or using Desmos or your graphing calculator, whichever one you choose, and type in the equations exactly how you see them. When you do that, 2x minus y equals 3. When you type in the two equations exactly how you see them, you will identify the intersection points at 0.667 and negative 1.667. Now, the book has the answer in fraction form. So if you can convert from fractions to decimals, that will be great. You need to learn how to do that. If you don't know how to do that, let me know. You can use the calculator to do so. And then the second point is -1, -5. So as you can see, those match the 2 points without having to do any algebra whatsoever. And the same thing for the next one. Type it in and you will see that they only intersect at one spot. Let me see if I have enough time. I do. So I'm going to go back to Desmos and I'm going to type in 2x squared minus 6x minus 8. And then I'm going to type in 2x minus y equals 16. And this is a graphically way. As you can see, if you click and hover, they intersect at 2 and -12. And I'm writing the ordered pair because these systems have the x and the y coordinate written in the system. Okay. If I have an x and a y variable, I need to write the x and the y coordinate as my answer. Unlike example 5. Example 5, as you can see, my system has only the x coordinate, so our answers is only the x coordinate. Okay. All right. And then let me see. What's my time like? I got 30 seconds. Okay, so what you're going to do here, I only have time to do one. You're going to graph the left and graph the right. So I'm going to graph x squared plus 9x minus 5. And then I'm going to graph the right side of the equal sign, 4 minus 3x. And as you can see, they intersect at 2 points. If you click and hover over the lines, they intersect at 0.7 and negative 12.7. So that is where those two answers come from. Only the x coordinate of the intersection point, because I'm only given the system with the x variable.